All right, if you're getting ready for your GCSE computer science exams, we've got to talk about something super important. One of the three big ideas in programming: selection. Trust me, by the end of this, you'll have it down. Let's get right into it.
Okay, so let's zoom out for a second. I mean, have you ever really stopped to think about how a game knows you've beaten the boss, or how your phone decides to pop up a low battery warning? How does any software choose to do one thing and not another? Well, that is the fundamental problem that selection is here to solve.
And here it is, the big answer. This whole decision-making thing in programming is called selection. It's really all about testing a condition, asking a sort of true or false question. And depending on that answer, the program knows which path to go down, which chunk of code to run next.
So the first tool in our toolkit, and honestly, the one you use all the time, is the if-else statement. The easiest way to think about it is like a fork in the road. Your program is walking along, it gets to the fork, it reads the signpost, that's the condition, and it knows whether to go left or to go right. Simple as that.
Now, for your exams, this is key. You've got to be comfortable with both pseudocode and actual Python. So on the left, you've got that generic pseudocode you'll see in the exam paper, using words like if, then, and else. But on the right, you see the real Python code. And the big difference to spot is how Python uses that colon and indentation instead of the word then. Getting that syntax spot on, that's what makes your code actually run.
Okay, let's make this real with a classic example. You can see here we've got a variable, airspeed velocity, and we've set it to 11. Then comes the if statement, and it's asking a simple question. Is the speed less than or equal to 11? Well, since 11 is equal to 11, the condition is true. So the program prints European. Now, if that speed was, let's say, 25, the condition would be false, and the code would skip right down to the else block and print Africa.
So when you really break it down, it's just a simple three-step dance. Step 1, the program looks at the condition and figures out if it's true or false. Step 2, if it's true, it runs the code that's indented right under the if. Step 3, if it's false, it completely ignores that first block and jumps down to run the code under the else. And the crucial thing is, it can only ever go down one of those two paths, never both.
Great, but what happens when life isn't so simple? A straightforward yes or no choice isn't always enough. Sometimes things are a bit more complicated, and our programs need to be too.
That's exactly the kind of problem we're talking about. I mean, just think about a cash machine, right? It has to give you options like withdraw cash, or check balance, or deposit money. You can't do that with just a simple if-else. You need a way to check for more possibilities.
And this is where Python gives us a super handy tool, elif, which is really just short for else if. Check out this code. The program starts at the top. It asks, is limbs exactly 4? If yes, it prints no one shall pass and the whole thing stops. If the answer is no, it moves to the next check, the elif. It's like this cascade or a waterfall of questions. It keeps checking one by one until it gets a true or it hits the very end with the else block.
Okay, hold on. Let's zoom right in on this one line here. This syntax, if limbs greater than 0, less than 4, is so powerful. It might look a little weird at first, but this is one of those cool Python things that you will definitely want to remember for your exam.
And here's the pro tip for your exam. What looks like one single check is actually doing two things at once. It's Python's clever shorthand for asking, is limbs greater than 0? And at the same time, is it less than 4? Remembering this little piece of magic can make your code look much cleaner, and it's a great way to show the examiner that you really get how Python works.
All right, we've got one more powerful tool to add to our selection toolkit. See, sometimes you don't care if a number is bigger or smaller than another. Sometimes you just need to check if something is part of a group. Like how a streaming service checks if a movie is in your watch list. For that, we have the in operator.
So, to see this in action, let's set the scene with another great example. Let's pretend we have a Python list and we've called it nigh. And inside this list are 3 bits of text: shrubbery, slightly higher, and a little path. This is the collection we're about to search. Now just look at how simple and clean this is. This line of code is basically just asking a straight-up question. Hey, is the word shrubbery anywhere inside that nin list? And since it is, the condition is true, and it runs the print command. It's a really direct way to test for membership. So the big takeaway, the thing to remember, is that using in is not just efficient for the computer, it's also incredibly readable for us, for people. When you look at that code, you know instantly what it's checking. And that is what good, clean coding is all about.
Okay, phew. We've got through the main selection tools you are absolutely going to need for your GCSEs. So let's pull it all together in a final summary. Think of this as your ultimate revision toolkit.
So here's the rundown. If you've got a simple this or that choice, you're using if-else. Got more than 2 options that can't happen at the same time, then you bring in if-else to build a chain of checks. And finally, if you just want to see if something is inside a list or a string, in is your best friend. 3 tools, 3 different jobs.
And really, that's what selection is all about. You've basically just learned how to give your programs a brain. They can now look at information, make a decision, and act on it. So I'm going to leave you with this question. Now that you know how to make your code choose, what incredible problems are you going to teach it to solve?